Hi everyone, welcome to Harvard Showcase, Harvard XR Showcase and Pitch Competition 2026. Our showcase event brings together experimental projects, research prototypes, speculative futures, and applied XR products in a curated interdisciplinary environment. This year's themes, from pixel to voxel, explores how immersive technologies are reshaping design, storytelling, and spatial experience across disciplines. And this year's showcase is organized into two tracks. The exploratory track focuses on research and creative work, emphasizing experimentation and new modes of perception. And the applied track focuses on venture and product-driven projects, highlighting real-world applications and scalable impact. This year's open call received more than 100 submissions from more than 20 countries, spanning academia, industry, and independent creators. All submissions were reviewed virtually by a panel of invited judges from academia and industry. After a rigorous first-round review, 12 finalist teams were selected to present today, and each team will present a 3 minutes live pitch along with an interactive demo located in room 121 and 123. We encourage all you to visit the demo booths and engage with all the project teams. And for all the teams who is going to present shortly, please make sure your pitch stays within 3 minutes limit. Each present will be followed by one question and the jury panel. So let's get started with the exploratory research and the creative XR track. And Leonid is going to present virtually first.
Hello, everyone. My name is Leon Kriktin. I'm an art director and visual artist of this project. I know today probably a lot of you gathered at this event from fields like architecture, XR, and creative technologies. But I wanted to talk today less about technologies that we used because there is so much focus on technology right now, and there is so little discussion about meaning and emotional impact among new media artists like me. And in my opinion, audience is craving for meaning and stories. This is a video of our Metamorphosis project. And it's not just a technical demo, but an exploration of shifting digital states. My computational art reimagines environment and our emotional impact from it. And this is not just random generative visuals. It is a study on how fluid, real-time digital environments influence human perception and emotional response. We're perceiving the spatiality of the work. It creates a digital atmosphere as a new way to define space through AI, code, and responsive virtual system that can sense you. The research goal here to seek how to lower stress and anxiety through aesthetic experiences of real-time responsive art. So look at these faces. We had people crying in our performances, laughing, and even deeply connecting to their inner self. AI responds here to both musical dynamics and the performer's movement. The visual environment feels like a living partner in the performance, not just a backdrop. And our audience engagement strategy began with the audience in relative darkness, allowing them to be drawn into the fragmented world, and ended with the audience feeling held by the same warm, organic environment that embraces the performer. Our performance is structured by 3 acts. The first act is a fracture, the second act is a recognition, and the third act is the metamorphosis, where the body remembers how to fly. Real-time logic I used here was including the Dutch designer and real-time AI. The metamorphosis happens in real time, meaning the artwork is living and it never repeats. The system architecture in this project uses sensors to drive the metamorphosis. And how about scaling up? Where does this go next? I think it can become, for example, large-scale architectural installations or mental health applications or healing art performances. The possibilities are many, and it depends in which context this type of project is applied. Thank you very much. Yes, yes, yes. Basically, we use the motion sensor cameras that were sensing the dancer movement in real time. Then the signal was going into my computer, and then the computer was going into the LED screen, creating the visuals, AI real-time visuals based on my prompting in real time. So basically, while I was looking at the dancer performing, I was also performing my visual system, feeding in real time the prompts that were prepared in advance for this performance. But at the same time, it wasn't automatically done. It was like purely like improvisation plus the music that was also used was also improvised, and it was also playing live. So basically, the whole environment was transformed by these visuals, by the performers, and by the music. And I think this impact from overall space was really emotional and really triggering kind of like deep emotional states in audience.
Yeah, thank you, Leon. That's time. Thank you for joining us from China. And we're going to move on to next team, Stage Forces.
Thank you.
Hi, thank you for having me here. I'm Topher Marafi. This is a collaboration between NCSU Virtual Production Lab and Alicardo, a visual effects studio out of Los Angeles. We took a hybrid AI approach to creating this film in every stage of production to reduce production costs, speed up turnaround of shots, and increase artistic quality for the director's vision. Here is a video showing some of the process.
Marafi with NC State's MadTech. This is exploring Gen AI tools in a virtual production pipeline. We collaborated with Colombian American film studio Alicardo on the award-winning short Las Fuerzas Extrañas. For pre-production, we used Blockade Labs' AI skybox generator and Magnific Mystic upscaler to create a realistic background in Unreal Engine. Then in production, we used AI for motion capture using Radical Live for the creature performance. I performed a virtual octopus and lighting in the LED volume while actors were able to interact with it in real time. And in post-production, we created a disintegration visual effect using Higgs field AI. Alicardo was impressed by the speed and quality of virtual production enhanced by Gen AI.
So the process of this had artists involved in every stage, and we were able to use these AI tools to create the structure that we needed inside of Unreal Engine for backgrounds. And then we're able to use it in performance in production so that the creature performance could interact directly with the actor and the voice actor. And we intend on using Capture in the future, which is a multi-camera AI system for this. And then in post-production, we were able to create a pretty sophisticated visual effect using start and end frame with Higgs field AI. But in the future, we're hoping to use more video-to-video AI tools that will give us more control through every frame of the sequence. And I think that's all of my presentation. Thank you.
Thank you. We have one question. Time for one question, please. Any question? No? Well, thank you, Topher. Thank you for joining us virtually. Next, we're going to move on to in-person team. Next team we have is Mediator. Please join us on the stage here.
Hi, good afternoon. Sorry. where can I do the click? Okay, cool. So my name is Jin. This is Mediator. Mediator is an interactive negotiation system for collective decision making. Also, this is my master thesis project. Yeah, this is a brief preview of what it is. It's actually all me that added together. So you are basically negotiate and reach consensus, and I built a table, physical table that actually outside of this room. Design is a process of reaching consensus. This is particularly important in the public decision making where multiple stakeholders need to negotiate and check and balance together. This is a case study that I did in Koto, which is a city in Tokyo, that it suffers from flood risk because of the low terrain elevation and also multiple historical events. So I divided the city into different categories of parameters like density, resilience, vitality, and greenery, so that we make decisions, build products based on real world to make influence to the actual site. Important thing is that you are not building products alone. You need to collaborate. You need to persuade AI and human to collaborate with you with different values. For example, the bank has a greedy in money, and this becomes a game flow that eventually drive this entire system that combines hardware and software. We integrate multi-agent learning, which is a reinforcement learning skill that basically train the AI to play the game millions of times, like AlphaGo, that drives the AI to make better decisions and combine a large language model to negotiate based on the suggested actions. And this becomes a chat room with AI that you are basically playing the game, building a park together, and trying to persuade AI and let AI persuade yourself. This is a process of making it, and you can definitely play around with people, negotiate, make better decisions. And this not only applies to urban planning, but also collective design, education, and also supply chain management in the business scenario. So this is it. Feel free to play it outside the room, one-to-one. Thank you very much.
Any question? Yeah.
So,
One question though.
so my question to you is, I saw in one of the renders a gentleman with a Quest on. What's the user experience of this in an XR context?
In XR context, I think XR is now related to see-through and mixed reality. This itself is an XR. That definitely you can wear, in the future you can wear a VR goggle or MR goggle to see the 3D projection beyond the 2D table. But currently it's a projected table that displays the board in real time. Yeah.
Okay, thank you.
All right, thank you so much. Next, we have Local Loop BKK.
Okay, got it. Good morning, everyone. We are Papet Inton and Peter Loftanov. We are here to introduce Local Loop BKK, a partially designed tool to engage the community and policymaker to create effective public space. So, I want to talk about the problem that affects city everywhere. Public participation often look inclusive, but in the practice, doesn't produce change. Participation is crucial, not the power. Community are invited to meeting, people share opinions, notes are taken, and yet those decisions aren't accounted for. This issue is not that people don't care, but issue is that there is not real system to translate public voices into actionable design outcomes. We test Local Loop BKK with community in the Thailand, where participation is often limited to one-way feedback. When people could actually see and modify proposal in 3D engagements, become more active and collaborative.
So this is why we created Local Loop BKK, a participatory design tool that transforms community needs into design requirements, generates modular 3D design options, and documents every decision in a dashboard that can be used by city planners and policymakers to support their local communities. We first start by collecting these community input and turning this into design requirements. From those structured design requirements, we then generate modular 3D assets using AI to kind of reflect those needs, like park benches, like shading, public needs. These assets are then loaded into an interactive dashboard where both residents and policymakers can design these public spaces in a simple visual editor. And since we track these changes and these multiple submissions, we can create a transparent feedback loop between the public and their institutions. This 3D visualization keeps proposals accessible and perceptible and keeps them very easy to understand so that communities can actually engage with what's being designed.
And the challenge is unique. Many rapidly growing city face that same gap between input and real outcome. And so from the idea to the practice, I listened, testing and feedback again. And from about the developed country to developed country. What if participation is not something people perform for a partner, but something they could see, negotiate, and own together? Right now, we working on the political party in Thailand and government in Thailand. Right now, we expand the city to work with the city of Boston. Who wanted to work with? Let me know.
Of course. All right. And thank you very much for it. If you have any questions, appreciate your time. What was the question again? I couldn't hear. So we're working with multiple examples. So like one of the first ones we were first testing was getting design feedback from communities in Bangkok, Thailand, like both the People's Political Party and like also like different type of communities. And so what we're trying to solve there is they gave a public space, like a physical certain location inside of Bangkok that we would like take that space from those design requirements of what objects they need. We then like created those 3D assets and put them into our dashboard tool where they can then like organize and put different proposals of how they want that space to be like used by the public so that both policymakers and the public can share those back and forth and kind of doing this like feedback loop of like, we want to put benches here, we want to put shading in this area, we want to be able to like meet into these third spaces that make them useful.
Sorry, one question.
Okay.
We can discuss on this our board. Thank you.
Yeah. Thank you.
All right, upcoming next is Team Shared VR, fly all the way from Italy to join us today.
Grazie a voi. So, questo per cambiare le slide, sì. Okay. Sorry. Good afternoon. We are Alice Cavasino and Fabrizio Sulpizio. We are researchers in extended reality and media at Polytechnic University of Turin. And today we're showcasing Shared VR, an artistic virtual reality experience that reimagine how people create, listen, and connect together. So, free users share the same virtual environment in which the boundary between the performer and the audience dissolves. You are not just a spectator, but you are the spectator. Everybody becomes a co-creator of event-transforming sonic and visual landscape. The experience is based on 3 layers. First, gesture. The body is the interface. All users interact by using their own hands. Second, procedural audio. So every sound is synthesized in real time from gesture data. Third, the environment that absorbs, stratifies, and remembers each contribution. The performance, so, is literally built by all users.
The experience unfolds across 3 acts, each one a deeper exploration of human-machine dialogue, as the system moves from passive responder to the very engine of the creative expression. In the first act, the user enters the virtual space alone, unaware that others inhabit the same environment. This phase centers on the one-to-one relationship between the individual and the system, inviting the user to freely explore the sounds they can generate on their own. The second act marks a turning point, from solitude to togetherness. Users find one another within the virtual space, and the system becomes the medium enabling multi-user interaction and collective co-creation. Each participant contributes their own voice to a shared world, experiencing in real time what the others see and hear. In the final act, the machine takes the lead. Interaction is suspended, giving way to a contemplative experience. Users become spectators of their own journey as the system draws from what has come before, combining and reinterpreting directions into something new. Shared VR was originally conceived by composer Michelangelo Lupone, with the audio dimensions developed together with the Conservatory of Music of L'Aquila and Academy of Fine Arts of L'Aquila. If you want to know more, please scan the QR code and visit our project page. Thank you for your attendance.
Thank you. What do you hope your users getting from this experience?
Thank you for the question. We want to we want to study how they experience the virtual world. If they perceive loneliness, and what happens when we join the users, if they effectively can contribute to reducing this loneliness, and what happens when we put the machine as a central to the artistic experience process. It's not just something that responds, it's something that co-creates and that enables a more meaningful experience.
Thank you.
Thank you.
All right. Our next team will be the last team to present in this track, which is AI-enhanced virtual reality for professional networking skills development. Thank you.
Hi, everyone. My name is Sean Jung from Purdue University. My team and I are working on something that I think a lot of people can resonate with, which is developing a networking skill and how to network in conferences or conventions like that. So here's some of the numbers that might surprise you. More than 70% of jobs are filled through personal connections, not just through job posting. So networking isn't just a nice skills to have, it's one of the most career-defining skill there is. But here's the problem, not everyone is good at this. And among the young adults, the social anxiety has increased over a decade. So for a lot of students, for example, just walking up to a stranger at a conference is just genuinely terrifying, right? So traditional workshops or role plays we provide, it just can't replicate the pressure of real events. So that's the gap we are trying to close. So some of the questions that we're asking here is, our goal is to build a networking simulator that feels real. We are developing a system where you interact with AI avatars within a virtual setting and a space that gives you real-time feedback and gamify things so we can keep people engaged. As we build a system, we are focused on these questions. Can this AI VR system actually train people more effectively than workshop or role plays? Does this digital confidence truly translate into a real world? So here's how our VR networking training works. So think of it as a video game that gradually turns up the difficulty level, but instead of monsters, the challenge is social pressure. So we start low stakes with the text-based conversations with the AI chat agent, which we've already built, so you can experience that in our booth. So next is in a VR setting. So learner enter into a virtual expo hall, interacting with the AI avatars, behave like a real exhibitors. So across this stage, we want to track for 4 core networking phases: how to approach, and how to build a report, and exchange a goal-directed conversation, and graceful exit. So what you're seeing here is our actual prototype in virtual reality built on Engage XR platform. And what you're seeing here is our actual prototype and The AI avatars named Jack and Karen, they have distinct personalities and then replicate the kinds of encounters that you will actually experience at a conference or expo. So yeah, success kind of looks like this for us. First is helping our most anxious learners find their voice in networking situations. Second is to ensure VR confidence stick in the real world. And third, making this tool cost-effective and accessible to everyone who's in need. And ultimately, we want to build a foundation to teach any high stakes interpersonal skills. Yep. So thank you so much. If you're interested in our project, please visit our booth.
Yeah, we're gonna have a quick switch of the tracks. So thank you, Alex, Terry, Kelly, and Alvin for judging the first track, exploratory research and creative XR track. Now we're gonna have next track, apply and venture product XR track. So we're also gonna welcome Amy, Gibran, Ori, and Shelly to the judging table, please. Thank you. And please give me your score sheet, judging sheet after you're done with them. Thank you.
Yeah, everyone who's in the door, please come. There's some seats.
We're missing.
I can find Gibran.
Just a reminder, all the project we're showcasing today will be in the demo booth, so feel free to check them out, play with their amazing products and projects in the demo booth after the presentation. Okay, so now we're gonna move on to our applied startup and product XR track. First, joining us on the stage is Inkphony. Thank you.
Thank you very much. Thank you for being here. So my name is Teja Shroff, and I represent Team Inkphony. Inkphony is an award-winning mixed reality application for the MetaQuest 3 and Logitech MX Pen. We've taken home some first-place prizes over the past year at some of the world's largest hackathons and have secured over $100,000 in funding so far. So thank you for your support. But what is Inkphony? Well, Inkphony is a app that transforms your space into a musical playground, and we do that using two things. We have a AI workflow that allows users to extract sounds from any object in their space, whether it be a coffee mug or a Christmas ornament. And then second, we allow users to create virtual musical staffs that represent music theory and music notation, and then allows your users to tap on these staffs to create virtual notes. And combining the two allows anyone to create their own spatial orchestra. And it's a whole new way of creating music. And speaking of creating music, the creation market for music is growing. It hit $7 billion last year, but there's a very large gap. And the gap is that the music interest in creation is growing, but the knowledge required to create quality music is shrinking. And so Inkfini actually crosses this gap because music theory and music composition are abstract concepts that take months to understand and years to master. And we shrink those months into minutes because Inkfini allows anyone to interact with concepts like chords and notation by just tapping on a surface. They can allow anyone to explore their space and create completely unique sounds, as well as create their own spatial orchestras, and coming soon, share those creations with the entire Inkfini community. So more than money, money is nice, but we would love help in distribution for Inkfini itself. Please come and see me if you're interested in working on the next generation of lifestyle applications. Thank you very much. Any questions as well?
Tejas, I've seen this demo when it was just created at the hackathon. I love it. It's super, super cool.
Thank you.
How are you going to make money out of it?
Yes, we are going to be a paid app in Q3 of this year, launching for $10. We would love anyone's advice and expertise on just distributing lifestyle apps in specific. Our monetization model isn't finalized, and we would just love your help with that. Yes, please.
Oh, sorry. Wired, or can you use your finger? Because now you have not one but two pieces of hardware.
That's right. We started with the Logic MX Ink Pen, but hand tracking is a first-tier input for this application and is the main input now.
Okay. Reach out to me because I have someone at Quest who does this.
Oh,
and
I love it.
Be willing to have a chat with you.
Thank you. My name is Tejas. Thank you very much.
All right, just reminder, so after each team, we only have time for one question, so please keep question and answer both short. Thank you. So joining us next is, I hope I pronounce his name right, because it's in Korean, HXR Ado, flying from South Korea to joining us today. Thank you.
How can I turn the page? Use the clicker here. Clicker here? Hi, I'm Yebi Chang, CRO of Voxel. We are a South Korea-based startup, and I'm honored to be here at Harvard XR. I'm proud to present HXR Edo, which won the CES Innovation Award for 2 consecutive years in 2025 and 2026. It is an XR solution for unresolved grief. SIT stands for Self-Insight Therapy, and Edo means morning in Korean. This is our wonderful team of XR specialists. We have one goal, to make sure our research actually helps people. The problem is that South Korea is now a super aged society, living under constant crisis. While we face an era of mass bereavement, there's still a lack of bereavement system to support those suffering. Our solution provides a virtual space for safe reconnection. For example, here's our client meeting her late husband through our platform. An XR therapist operates virtual avatars, including speech, facial expressions, and gestures in real time, ensuring a safe and guided therapeutic experience. This is a core technology behind our solution, innovative Gestalt empty chair technique. This year, we are moving beyond the screen by operating our first physical memorial space called Good Morning in South Korea. So far, we have helped 12 families. These are their testimonials. our study shows a 42.7% reduction in depression and a 37.6% drop in anxiety after just one session. We were featured on national news for supporting a client who lost her sister in a sudden tragedy. She told us she had been speechless whenever she visited her sister's resting place. Through our solution, she finally found her voice to say her final goodbye to her sister. And this is why we exist and why we are committed to scaling XR Edo across borders. So if you have any questions, please visit our booth. I'll be happy to answer. Thank you so much.
You mentioned that you had worked with 12 families. What are the next steps coming in the near future?
That's a very good question. We are still expanding our business to B2B and B2C. So we would like to help as many as families if they're seeking help. Thank you very much.
Next team joining us is Strida. Thank you.
How do I move to the next slide? Okay. Hello, my name is Jingo, and today I am presenting Strada. It is a design tool for spatial computing. Think about Figma, but for XR. Apple, Google, and Meta are all racing to ship lightweight and consumer-ready hardware. The XR hardware are maturing fast. As the hardware gets more adoption and goes mainstream, naturally, app teams want to bring their existing products into these platforms. There are existing dev frameworks that allow developers to convert their existing apps into XR experiences. However, the problem is that before any of the dev work can happen, designers need to design the spatial experience first. That's where things break down. Designing for spatial is hard, and the tools that designers rely on every day right now, like Figma, are never built for XR. There are enormous challenges at every single stage in the current XR workflow. You need expensive hardware, you need technical expertise, and it causes long iteration cycles. Strada is built around the mission to simplify XR prototyping and sharing for UX designers. You can think of Strada as the Figma for XR. You can create directly on the browser. And once you are ready, it's a single link. It works on any devices, computers, phones, even phone-based AR glasses, and XR headsets. And now I would like to, in the last part of this presentation, I'd like to show a demo video. And that's it. Thank you so much for listening.
Thank you for this. Pretty cool. There's a bunch of tools out there that do similar things, and there's also a new wave of tools like Vibe Coding XR by Google and others that are doing it without even typing any of that stuff. So how do you compete with these?
Yep. I think I'll take that as two questions. The first one is how to compete with web-coded experience. I think in the future, there are room for both. One is personalized vibe code experience, and the second one is carefully crafted experience. And Strata is really targeting the second group, the app teams that really want to bring carefully crafted experiences to the end user. And I mean, like Figma is facing the same issue, and we're not seeing Figma doing any worse than before. So I think there will be room for both. And the other question is how I compare with other existing XR design tools. I think the biggest player right now is ShapesXR. Compared to ShapesXR, Strata is completely web-based. You do not need an XR headset to do anything. So ShapesXR, you need a headset to view or create the prototype. For Strata, it works on any device. Yeah, it works on web. Yeah, thank you.
Thank you. Up next, we have Siglass. Thank you.
All right. Okay. Hey, everybody. I'm Brandy Freitas. I'm the Director of Data Science and Analytics at Siglass. We're a startup that focuses on rendering and quantifying very large volumetric data in virtual reality. We're in hundreds of research labs, universities, and companies all over the world that focus on using microscopy data to ask questions and solve problems. We came out of a neuroscience lab that had originally worked with confocal microscopy data and have since expanded to work with advanced. Oh, there we go. Okay. Click harder. Okay. We come from a neuroscience lab that had originally worked with confocal data, and essentially we've expanded to work with almost any kind of volumetric scientific data sets. And that includes light sheet, which is what you're seeing here. This is a mouse brain, to micro-CT, to holotomography, MRI, anything that's collected in 3 or 4D with time. Microscopy is expanding rapidly, and researchers are increasingly facing a problem. Their data are too large and too complex to examine with commonly used tools, especially on 2D screens. They lose the context of their data, which is so important for what they're doing for work. Particularly with new modalities like light sheet data and micro-CT, we're looking at hundreds of gigs to many terabytes per data set, which is often impossible to open and work with. We built Siglass from the ground up, focusing on using PCVR to solve this problem and improve the workflow to analyze microscopy data. We do this using out-of-core Octree rendering. Out-of-core means that the system doesn't load the entire data set into GPU memory at once. Instead, it streams in only the parts that are needed to render what the user is actually viewing. And the Octree is a hierarchical spatial data structure where each 3D volume or cube is recursively subdivided into 8 smaller cubes. So this helps with level of detail management, and it also has an efficient culling of regions not in view or not contributing meaningfully to the current image. So as I pull data close to me, those disappear. So together, this method allows for very fast, memory-efficient work. All right, so this is some of the analytical tools that we have built in. You can see here, we have also incorporated, and this one on my end, a lot of more advanced AI to do this work. All right. And then we've also come with Sony. We've partnered with Sony this year to bring in their spatial reality display. So if you come see me in the booths back there, you can interact with this and check it out. It's been really neat to see. So that's me. Thanks.
Are you ever able to leverage this for nanoparticle data? I'm actually working with a company right now on a BCI leveraging electromagnetic nanoparticles, and I think they'd be very keen to take a look at this.
Yep, absolutely. Yeah, so any data that are in 3D or 4D, and then also we're able to render things that would be more like this. So this is a UMAP. So this is representing individual cells. So for the nanoparticle work, I can imagine seeing that like this as well. Yep. Thanks.
Okay, our next team is Grand Tour XR.
Where's the pointer? Just click this one. All right. Hi, everyone. We are Team Wonderlands Lab. Next one. Okay. Okay, I'm Zihao, co-founder of Wonderlands Lab, and standing with me is Hongming, co-founder. Yeah, so our teammates are from MIT Media Lab, Unity, Meta, and Pico XR. Together, we created Chinatown Arcade, New York City's first outdoor AR and AI-powered scavenger hunt in collaboration with Snap. So that project inspired us. We should go to the next one. Yeah, it's this one. So together we created Chinatown Arcade, New York City's first outdoor AR and AI-powered scavenger hunt in collaboration with Snap. That project inspired us to build Grand 2 XR, and here's a quick look.
Hi, I'm Ziha, a tour guide based in New York City. I started giving in-person walking tours in Manhattan, Chinatown. However, I quickly reached the tour capacity and want to reach out to more people, especially those who are unable to visit in person. And that's when I found the perfect solution. Grand 2 XR. Now, I capture the same real-world locations using Gaussian splatting and post them on the web, so people can join my tour anytime from anywhere. By simply clicking the link on whatever device they have inside the tour, everyone has their own avatar. I guide their attention using pointers, show historical photos, and they can even step into the past through our AI-powered reconstructed scenes. The best part? We can talk in real time using our actual voices.
Look, I'm here. Oh yeah, back rub. Oh yeah, this looks like a pretty reasonable price.
We don't have feet though.
Yeah, we don't have.
When I'm offline, my AI companion Pinball takes over, answering questions and guiding visitors through the tour.
Yeah, where's the best bubble tea around here?
Ooh, head to VV Bubble Tea on Byron Street. Absolute classic, super tasty.
Thanks for joining. I hope to see you soon on Grand 2 XR.
So we won the first place globally in the Immersive Travel and Destination track at XRCC Hackathon, sponsored by German National Tourism Board. Since then, we have signed paying clients, including China Institute, American, and others. But through this work, realized our pipeline can fit a much bigger market, real estate, specifically venue rental. $20 billion growing fast. 63% of buyers already decide without visiting in person. Listings with virtual tours get 87% more views. The demand is there, but the tools are not. So we built Arbitour AI, one tool that helps you showcase, engage, and convert, delivering 87% more engagement and 67% higher booking conversion. We use Gaussian splatting, faster and cheaper to capture than traditional 360 panoramas. Visitors can get an immersive 3D walkthrough, move freely as if you're actually there. Our AI tour guide hosts them 24/7 with real-time spatial understanding. When they're ready, they schedule a live guided tour with a real person, seeing 3D zoom to build trust. And virtual staging. Owners can show furniture layouts and capacity to help clients commit faster. And on top of that, all the Gaussian splatting data we capture is extremely valuable for physical AI, specifically robotic simulation, lower cost, much higher quality than static data. And this is our roadmap. And thank you so much for your time.
Yeah, I really like this idea. I actually live in New York. I wish I had this. You know, I work right next to Chinatown, so maybe I should get on your platform. But yeah, this is really cool. Just a quick question I had. You're about to get onto it. So how do you guys see you guys scaling? Like not just doing tours and real estate. Like where's the room for growth for scaling this idea?
Yeah, sure. So right now, for like specifically in the real estate, we're like targeting the venue rental niche because like in New York City, there's like tons of events going on every single day, and a lot of them they actually book the space before they visit in person. And yeah, so we found this like pinpoint both for the event organizers, for the space owners, and also for the audiences. So we're decided to just find this niche and basically provide tools for them, and that's basically our plan to scale right now. Thank you.
All right, our last team of the day is interface.
Thank you. Awesome. Hi, everyone. I'm Max. We're Interface, a research lab for spatial intelligence based in Manhattan. We're actually in stealth currently, so this is the first time we're sharing what we're working on in a context like this, so thank you guys all for being here and for listening. So a quick background on ourselves. So simulation has been the through line for our career. Both myself and my co-founder Peyton studied at MIT. I did research there on simulation of everything from humans to cities to infrastructure, and Peyton on real-time high-performance compute systems. We also grew up playing iconic 2000 sim games, everything from Roller Coaster Tycoon 3, Age of Empires, SimCity, and that very much infected us for our entire career. And then the last bit of context is I also cross-regged at Harvard to do human rights, and Bria from our team also graduated here. So it's really good to be back, and thank you for letting us close out this pitch event. So what we're working on. So our core thesis is pretty simple. Training AI on text has already been done, right? On all the text and the video on the internet has already been done. And the next wave is actually, can we train AI more like humans? If we can do this, we can help it to develop a more multimodal and more intuitive understanding of the world around it. That's really how humans learn. We don't just read, we really interact in action-conditioned environments, and our actions have consequences. And this is how we train intuition in our own understanding. And so our core thesis is, can we create these fully simulated, photorealistic worlds in which we can place AI, and then it can actually learn much more like humans learn? So how do we actually do this? To simulate the real world, photorealistic, at huge scale, highly optimized, we realized we needed to fundamentally re-engineer the entire rendering process. It was not acceptable or possible to use traditional mesh-based pipelines, the sort which have been used for decades in artist-driven workflows in platforms like Unity and Unreal. What we actually had to do was pass a huge amount of data to these machine learning models so that it could directly generate these photorealistic representations. And this is called neural rendering. So what we do is our team is currently working on training 2 models, one for neural rendering, the foundational Gaussian splatting model for actually generating these objects in these scenes, and then also another model for generating photorealistic characters and avatars, like, for instance, this one, which then interact within these photorealistic scenes. Where we're going with this, our vision is to generate a world-scale simulation across multiple cities within which AI can learn and interact. This will be a browser-based experience where anyone can log on, create scenes, put agents in them, see them act out historical reenactments, social simulations, games, and where we're going first is New York. So we're constructing a new building in New York with which you'll be able to log on, create all of these scenes, and then we're moving to London, Tokyo, and full-scale city simulation. Thank you very much. If you're interested, we're hiring. Cool. Thank you, guys.
Thank you. Yeah, next slide. Next slide. Yeah. Okay. Thank you very much for joining our showcase competition today. So that's all our 12 teams that we select out of like over 100 teams globally. And we want to thank you, our judges who are judging our final round today: Alvin, Alex, Kelling, Terry, Amy, Gibran, Ari, Shelley, and also our first round judges who judged the first round virtually like a month ago. And thank you all for your support, and we're looking forward to the winners. Yeah, please, after you finish the judging sheet, you can give it to me. Thank you.